All right, so in 5-4 today, we're going to be multiplying and dividing rates. And the main thing we're going to be doing is working on conversions. So changing things from minutes to seconds, from feet to miles, so on and so forth. So the big idea, when rates are multiplied or divided, the unit of the answer follows rules of arithmetic on the units of the original rates. Okay, so basically, we're going to be using all of this canceling that we've been doing with multiplying and dividing our rates. When you've got the same variable on the top and bottom, they cancel, so on and so forth. Okay, we're going to use that to help us translate different units into comparable units like minutes and seconds. All right, so it says what are the conversion rates of each of the following? So we know 1 minute equals 60 seconds. So I want to write that as a ratio, and there's always two ways to write the ratio. So we can write it as 1 minute over 60 seconds, or we can write it as 60 seconds over 1 minute. So those say the same thing. 1 minute compares to 60 seconds, 60 seconds compares to 1 minute. And so depending on how we need things to cancel in the problem we're working on, we might have to flip-flop how we write that. So same thing here, 5,280 feet is the same as 1 mile, but we could also write 1 mile is the same as 5,280 feet. And then obviously following that same logic, 1 year is 12 months, so there's two ways to write that. 1 year over 12 months, or 12 months over 1 year. So it all is going to depend on the specific problem that we're working on. So let's jump right in so you can see what we're talking about here. So number 2, on average, an adult human heart beats about 70 times per minute. At this rate, how many times does a heart beat in a 365-day year? So we've got something that's in minutes, and we got to get all the way to years. So I would start with minutes, and I got to get minutes into hours, and then I got to get hours into days. And then once I know how much it's going to be in a day, I can figure out how much it's going to be in a year. So here's how we're going to set this up. Our original ratio here is how many beats in a minute. So let's set that up. 70 beats, 1 minute. And I'm going to expand that out now, and I want to get all the way to an hour. So go from a minute to an hour. So I'm going to multiply this by another ratio, by another one of these conversion rate. Now what you want to think about is I want things to kind of cancel out. I want to go from minutes to hours. So I'm going to be talking about how many minutes are in an hour. I'm going to be using 60 minutes in 1 hour. So what I'm going to be using is either 60 minutes for 1 hour or 1 hour for 60 minutes. So I'm going to be using one of these, and I'm going to be multiplying it times this. And what I want is how many beats per hour. So this says beats per minute. I want beats per hour. So if I were to put the hours on top and the minutes on the bottom and multiply, I'm going to have beats times hours and minutes times minutes. And nothing's going to cancel. I'm going to have some weird thing that I'm not really looking for here. So what I want is minutes on top, so they cancel with these minutes. And I want hours on the bottom so that after these cancel, my new formula is going to say beats per hour. So I'm going to go ahead and I'm going to put 60 minutes is 1 hour. And when I have minutes on the bottom and minutes on the top, they will cancel each other out. And so if I want to turn 70 beats in 1 minute to how many in an hour, I'm basically going to be multiplying by 60 because these are going to cancel. The 1 times 1 doesn't do anything, so it's going to be 70 times 60. So let's go ahead and cancel those minutes out. So before I actually run the numbers, because that's just going to be one extra step, we can do this all at once. Once I have things in an hour, I want to turn it to days. We're trying to get all the way to a year. So how many hours are in a day? Well, 24 hours in 1 day. I'm going to want my hours to end up canceling out so that it's days. So I need to put my hours on top. So I'm going to be multiplying this by the conversion of 24 hours is 1 day. And if you take a look, when I set that up, hours is going to cancel hours. And so if I do the 70 times the 60 times the 24, that's going to tell me how many beats for a day. And once I know how many days, I want to go to years. And so the conversion is 365 days for 1 year. I'm going to put the days up top so that it cancels this day. So 365 days is 1 year. And so we know that the days will cancel days. And so I've got this all set up where everything's going to cancel except the beats and the year. So my final answer here when I actually run the numbers is going to be how many beats there are in 1 year. And that's what I'm looking for right here. So all I have to do is multiply 70 times 60 times 24 times 365. And if you did that, it comes out to 36,720,000. Now we still have beats on the top. And 1 times 1 times 1 times 1, so 1. And the only thing left on the bottom is year. So it's this many beats per year. And you could write that out without the big fraction. And you could say beats per year. So that's another way to write it. So 36,792,000 beats per year. So some of you could have thought about this in your head and said, well, I've got 1 minute. Let's times it by 60 to get an hour, times 24 to get a day, and times 365 to get a year. But we're showing why this works and how we can use these rates to cancel. And sometimes it's not going to be something that's quite as easy to do in your head, and you're going to want to actually set this up and start canceling things. So let's look at example number 3. On average, Cairo gets 2 millimeters of rainfall per month. How much rainfall does it get in 1 year? So we're going from per month to per year. So you might say, well, if I know how much for 1 month, I'm just timesing by 12. And that's right. But let's set up the conversion rate and show how things cancel. So right now our ratio says we have 2 millimeters per month. So 1 month. And I want to go from months to years. So I want to multiply by the conversion rate that goes from months to years. And I need months to cancel. So I want to put my months on top. Okay, so I'm comparing months to years. Months to years. So I want to get this to just 1 year. So 1 year is going to compare to 12 months. So I could have done this either way. I could have put years on top and months on the bottom. I chose to put months on top and years on the bottom so that these months would cancel out. The units would cancel. And then once we run the numbers, we've got millimeters per year. So when I run this straight across, 2 times 12 is 24 millimeters. And on the bottom, 1 times 1 is just 1. And the only unit left on the bottom is year. So my final answer, 24 millimeters per year. That's how you can write out your answers. This is fine as well. Okay, let's flip it over. All right, so a cheetah can reach speeds of 70 miles per hour. How fast can it run in kilometers per hour? So we're going from miles per hour to kilometers per hour. And they're going to give us the conversion because we may not know that one right off the top of our head. So we're going from miles to kilometers. 1 mile is the same as approximately 1.61 kilometers. It's rounded. That's why it's approximate. So starting with what we have, we know that the cheetah runs 70 miles in 1 hour. And I want to put this into kilometers. So this is going to be my ratio. It's going to be a fraction, either miles over kilometers or kilometers over miles. And I need to kind of look at my initial setup here. I want miles to cancel out so that it's kilometers. So if I put miles on the top, it doesn't cancel this miles. You'd have miles squared or square miles when you multiply across. And that's not what we want. We want the miles to go away and leave kilometers on top and hours on the bottom. So when I set up this comparison over here, I got to put kilometers on top. So it's going to look like this. So 1 mile goes on the bottom. So I'm comparing kilometers and miles, but I've chosen to put kilometers on top. So the units of miles will cancel each other. And now I'm going to end up with some number is kilometers per hour. And that's what I want. So when I multiply straight across here, 70 times 1.61 is 112.7. The miles have canceled, so that's kilometers. And that is in 1 hour. So if I was going to write out my final answer, it's 112.7 kilometers per hour. Okay, and the last one. So a penny has a thickness of about 0.08 inches. How high to the nearest tenth of a mile would a stack of 1 million pennies be? All right, so let's start off with the comparison that we have. 0.08 inches for 1 penny. So we got to go all the way from inches to miles. So first thing you should do is go from inches to feet, and then we'll go from feet to miles, because 1 mile is equal to 5,280 feet. We did that on the top. So if we can turn the inches into feet, we can turn the feet into miles. Okay, so we're going to multiply this now by the conversion that's going to go from inches to feet. So our other conversion is 12 inches equals 1 foot. So that's what I'm going to set up here to go from inches to feet. And now I got to think about, what do I want to cancel? I want my inches to cancel, so it's just feet. So where am I going to put them? Am I going to put my inches on top? Am I going to put 12 inches over 1 foot, or 1 foot over 12 inches? Well, I want my inches to cancel, so it's how many feet for a penny. Okay, so I'm going to go ahead and put my feet up top compared to how many inches there are. When I do that, my inches will cancel. So when I multiply here, I'm going to end up having feet compared to pennies. Now, once I have it in feet, I got to turn it to miles, because that's what the question is asking me. So I'm going to set up this comparison, my miles and my feet, and I need this feet to cancel. So I'm going to go ahead and put my feet down here. So my 1 foot cancels these feet, and that's 1 mile. And that is going to go ahead and run everything through for me. Now, that's just converting the inches to feet. This is talking about 1 penny, and we want to know how many for 1 million pennies. And so we're going to have to multiply this now by 1 million pennies. And any whole number is actually just over 1, so we can throw that over 1. So going back to where we came from, we started out with 0.08 inches, okay, for 1 penny. We want to take 1 million pennies. So you could have actually started off here and changed this into 1 million pennies, but we're just going for 1 penny. And we want to convert that into miles. So how many miles? So this would be a really small number. Okay, but we're going to multiply it by 1 million, because obviously we don't want to know how many miles 1 penny is, because that would be a super, super small number. So we want to know if there's 1 million pennies. So this initial conversion right here is turning this 0.08 inches into miles, but that's again for 1 penny. And so now we want to take it and put that into 1 million pennies. So we're going to take this distance and multiply it by 1 million. All right, so if we run all those numbers, 0.08 times 1 times 1 times 1 million, we're going to get 80,000. And if you multiply here on the bottom, 1 times 12 times 5,280, it comes out to 63,360. And let's go ahead and look back here. This 1 penny is going to cancel with these pennies. And so when we go to put units here, the only unit left on top is miles. So that means this 80,000 represents miles. And when you look on the bottom, there's no units left. They've all canceled. So this is just talking about miles. And so what I want to do is I want to divide this number so it actually becomes something. So this represents a number, 80,000 over 63,360. That's how many miles it is. And so I'm going to go ahead and I'm going to divide this to turn that into a nicer number to look at. So 80,000 divided by 63,360 looks like this, and we'll round it off a little bit. So let's go 1.26. So approximately 1.26. And again, that's just from this division problem right here. And that's going to be my answer, miles. If you wanted to round that up and call it 1.3 miles, that would probably be more appropriate. If you look back at what it asked for, it said to the nearest tenth. So this is what they want. And so if we take 0.08 inches for 1 penny, we convert that into how much of a mile that is, and then multiply it by 1 million for 1,000,000 pennies. Those 1 million pennies are going to stretch out 1.3 miles.